Hello everyone. Today we have an interesting task at hand that involves solving a problem using the emission spectrum of the hydrogen atom. To successfully tackle this problem, we need to be familiar with a formula that calculates the energy. This formula includes the Planck constant, the speed of light, and the wavelength. Additionally, there is an extended formula that we require for this specific problem involving the Rydberg constant. It's essential to remember this value for later use. Let's take a look at the conditions of our problem. We need to determine the wave number for the third line found in the Balmer series. In order to accomplish this calculation, we need to understand how these lines are distributed and how we can substitute the necessary values. For each line, whether it's the first, second, or third, we have variables to consider. The variable n represents the level to which the electron descends from the upper levels, while m refers to the upper level from which the electron descends through the energy levels. Now, let's focus on what we need to do. Our task is to calculate the wave number for the third line, so we will substitute the values of n and m accordingly. For the Balmer series pattern, we substitute n as 2 and m as 5. This substitution allows us to progress with our calculation. In order to proceed with the substitution, we require additional information. 1 divided by lambda, substitute here the values of the constants and the values of the levels being discussed in our problem. Now let's move forward with the substitution process. The constant we will be using is 100 and 9,678. Inside the parentheses, we will substitute accordingly. In this particular case, we have the value for n as 2, so we will square it and subtract 1. Additionally, we'll substitute m with the value 5, which will also be squared. This calculation will yield a result of 4,387. This specific value represents centimeters minus 1. We can also express the wavelength as 2 and 3 times 10 raised to the power of negative 4 centimeters raised to the power of negative 1. This process serves as the foundation for calculating this specific line. I encourage you to take a moment to review this information, as it will help you approach the problem involving the Balmer line on your own. For example, if we were dealing with the first line, we would replace n and m with their respective squared values, 2 squared and 3 squared. In a similar manner, if we were tasked with performing this calculation for the second line, we would substitute n with its squared value, 2 squared, resulting in 1 divided by 4 squared. While these types of problems may arise during your studies, they are not overly complex. By remembering the key formula, being aware of the constant's value, and accurately executing the necessary calculations, you will be well prepared to handle them. Goodbye.